At 4:51 in the morning, one number appeared on phones across New Zealand. 5.9. Near Taumarunui, cupboards shook and people hurried out of bed. Far away, a hanging light moved gently. Some people slept through the whole thing. It was one earthquake, but it did not create one experience. The first lesson is simple. An earthquake has one magnitude, but it has many intensities. Magnitude describes the event at its source. Intensity describes what the shaking did in each place. Mix those two ideas together, and a simple number can become much more frightening or much more comforting than it should be. The earthquake on July 25, 2026, was centered about 5 kilometers south of Taumarunui. Its best measured magnitude was close to 5.9, and its depth was about 9 kilometers. It was reported across a remarkable distance from Northland to Otago. 8 smaller earthquakes followed in the first hours. No damage had been reported when the morning news bulletin was broadcast. How can a quake be described as severe near its center, felt hundreds of kilometers away, and still leave many places untouched? Begin underground. When rock suddenly moves along a fault, energy travels away as seismic waves. Instruments record those waves. Scientists use the records to estimate the earthquake's location, depth, and magnitude. Magnitude is a measure of the earthquake itself. Moving one whole step up the magnitude scale means about 10 times the measured wave size and roughly 32 times the energy. A magnitude 6 is therefore not just a slightly larger version of a magnitude 5, but that larger energy number still does not tell you exactly what happened in your kitchen. The waves have to travel from the fault to your house. A shallow earthquake begins close to the surface, so nearby communities may receive stronger shaking than they would from the same magnitude far below them. Distance usually weakens the waves. The rock and soil on the journey can change them. Soft ground may move differently from solid rock. A hill, a basin, or layers of sediment can make neighboring places shake in different ways. The building then joins the story. A light timber house, an old brick wall, a tall office building, and a water tank do not respond in the same way. Different waves and different shaking periods can affect each structure differently. Objects that are fixed to a wall behave differently from objects balanced on a shelf. This is why intensity is local. New Zealand uses the Modified Mercalli intensity scale to describe effects. At level 3, people indoors may notice a light vibration. At level 5, almost everyone indoors may feel the earthquake and small objects can move. At level 6, walking steadily can become difficult and slight non-structural damage may occur. At level 7, the shaking is called severe, and a few weak buildings may be damaged. One earthquake can produce several of those levels at the same time. Close to Taumarunui, the first computer model estimated severe shaking near the earthquake. That was not a second magnitude. It was an estimate of local intensity. Farther away, the same event produced lower intensities, even though the magnitude remained 5.9 everywhere. The maps also tell two different kinds of story. One comes from machines. Strong motion sensors measure how the ground moved. Computer models combine those readings with the earthquake's magnitude, depth, and location. For earthquakes of magnitude 3.5 or greater, an automatic shaking map can begin appearing within about 20 minutes. Scientists may improve it as better information arrives. The other story comes from people. When someone taps a picture in a felt report, they are not voting on the earthquake's magnitude. They are describing what happened where they stood. Did a window rattle? Did an object fall? Was standing difficult? Thousands of small observations can show the shape of the shaking between instruments. The reports are grouped into areas, so the public map does not reveal a person's exact address. That human layer is especially useful because a sensor cannot see every room. It cannot know that a book fell in one house, while the family next door noticed only a soft roll. Felt reports have a limit too. More reports often come from places with more people, better internet access, or greater interest. A dark patch on a map may partly show population. It is evidence, not a perfect photograph. This leaves a practical way to read the next earthquake notice. Look at magnitude to understand the overall size. Look at depth and distance to understand how far the waves traveled. Look at the intensity map to understand the likely effects in different places. Then look at local reports and official advice before deciding what the event means for you. During the shaking, none of those numbers should delay the first action. Drop, cover, and hold. Most earthquake injuries come from objects falling on people, so protect your head and neck and stay with your shelter until the shaking stops. Afterwards, the numbers can help you make sense of what just happened. 5.9 was one fact about the Taumarunui earthquake: the cup that moved, the road that stayed open, the shelf that held, and the town that felt the strongest jolt were other facts. If somebody you know reads magnitude as a single danger score for the whole country, share this story with them. The earthquake had one size. New Zealand felt it in thousands of different places.